Welcome to 8.2 on the Pythagorean theorem. This is one of the biggest parts of geometry that we'll learn this year. Luckily, you're super prepared by already having learned how to do radicals, and you have a strong algebra base, so it shouldn't be too bad. So, the Pythagorean theorem helps us solve for the length of sides in a right triangle. So before we start, we should figure out what the different names of parts in the right triangle are. So if you look at your notes section, the first one, in the triangle to the right, the hypotenuse is side C. So it's this guy here. It's that diagonal one. We know that this is the hypotenuse because the hypotenuse is always across from our right angle, which of course you know is in the corner here with the little square. That means that it's a right angle. So even if this triangle were rotated, we would still know where the hypotenuse is because it's across from the right angle. We also know that the hypotenuse is always the longest side. You can try it out, draw a couple triangles. You will notice that the one across from the right angle is always the longest. In the triangle to the right, the legs are sides A and side B. So just rewriting that on the triangle here, this guy we call hypotenuse, and these two, A and B, we just call legs. So the Pythagorean theorem tells us a formula for the lengths of these sides. The theorem itself, or the formula, is this. It is a squared plus b squared equals c squared. I made that nice and bold because you're going to use that again and again and again. Just to remind yourself, A represents a leg, so the length of one of the legs. B represents also a leg. And C represents the hypotenuse. Let's do two of these examples together. You got some practice to do on your own on the back. If I scroll down some, example 1, we have this triangle here. It's got two different legs and a hypotenuse. Leg 1 is 3 long. Leg 2 is 4. It really doesn't matter which one's 1 or 2, as long as you know that both of your legs are 3 and 4. And the hypotenuse we don't know. It's typically represented as C. So, now that we've got two numbers and one variable, we're going to write our Pythagorean theorem, or the formula, which is a squared plus b squared equals c squared. In the formula, we said that the two legs were A and B, so we're going to plug in numbers for A and B. A, I'm going to make 3, so we've got 3 squared, plus the other leg, which is 4 squared, equals c squared. So 3 squared plus 4 squared equals c squared. This, once we solve it, will give us the length of our hypotenuse. We can simplify 3 squared, type it into your calculator, or maybe you just know it. 3 squared is 9, plus 4 squared. 4 squared, or 4 times 4, is 16. And that is equal to c squared. Then we can clean up 9 plus 16, type it into your calculator, or figure it out in your head. That turns into 25. So now we have 25 equals c squared. And then finally, if we want c by itself, we need to cancel out the little squared part. And we said that the opposite of squaring something was taking the square root. So in other words, the square root of 25 is equal to c. And then we can simplify that last piece. The square root of 25, we all know, is just 5. So our final answer is that c equals 5. In example number 2, we've got some different sides to solve for. One of our legs is 3, The other leg, we don't know. Typically, we use A and B to represent our legs. So I'm going to put B in this blank since it's my second leg. That's representing this side here. We don't know how long it is. Our hypotenuse, the one across from the right angle, is 7. So I'll put that here. We'll start with our Pythagorean theorem, which is a squared plus b squared equals c squared. We'll plug in a number for a, which is 3. Make that squared. We don't know what b is, so we're going to leave that alone. Plus b squared. And finally, we do know our hypotenuse, or c. That is 7. And the formula tells us to square it. Next step, we can figure out what 3 squared is. That's just 9. We'll leave our b squared alone. And we can figure out what 7 squared is. That gives us 49. We're close to the end. Now we've got to do a little bit of algebra. So we have a variable right here, but we've also got some plain old numbers on this side. Let's get just the variables on the left by getting rid of the 9. We can do that by subtracting 9 from both sides. These two cancel out. We're left with a b squared, and on the other side, we have 40. And finally, we need to cancel out the squared part of b squared. The opposite of squaring is taking the square root. So we've got b equals the square root of 40. That's pretty good for an answer. It's totally correct. However, if your question tells you to simplify your radical, then we need to do another step of simplifying. If you remember from 8.1, or you look back at that sheet, I'm going to use the perfect square method because I think it's the fastest for me, but you're also welcome to use the prime factorization, which is where you draw out your ladder. But for me, I know that b is equal to the square root of 4 times the square root of 10, and I can simplify the square root of 4 to just turn into a 2. So I have 2 times the square root of 10, and that would be my final answer.